Good day and welcome to chemistry tutorial with tutor Tayo Emmanuel Yudun. And today we are going to be looking at this interesting question on electronic configuration. Write the electronic configuration for the following: chromium with atomic number 24, then Cr3 plus, chromium ion, copper atomic number 29, and Cu2 plus, that's copper ion. So let's go one after the other. Now, these two elements and their ions was picked intentionally for the class today, so you can understand how to appropriately write for them, because they have a kind of exemption a little bit from the pattern by which other elements electronic configuration are being written. So follow carefully. So for chromium, by now you should know that when element is in the ground state, when it's not carrying any charge, the atomic number, which is equal to the number of protons, will be equal to the number of electrons because it's carrying no charge. If there's a charge on it, the number of electrons will not be the same like that of protons. But because there's no charge, this is also the number of electrons. So we now go 1s2, 2s2, 2p6, 3s2, 3p6. Now the energy level of 4s is lower than that of what? 3d. But you observe that I have not put anything here first, isn't it? Now many would think it will be 4s2, then 3d4. But this is not the correct way of writing the configuration for chromium. Now why is it like that? For the d orbital, it has 5 suborbitals, isn't it? The d orbital has what? 5 suborbitals. Now if you are to draw for this, follow carefully. D orbital has 5 suborbitals. It means you have, according to Ohm's rule, 1, 2, 3, 4. Leaving this space empty is not a stable configuration for chromium according to research. Hence, there will be an excitation of one of the electrons from the 4s, making it 4s1, down to this place, and making this one 3d5. So the correct configuration for chromium is like this, and not the way I wrote it the other time. Okay? So let's now write for Cr3 plus. 3 plus means it has lost 3 electrons, means it has 21 electrons, right? So let's go 1s2, 2s2, 2p6, 3s2, 3p6. This is the configuration of argon, and in some cases you could just represent this using argon. Okay? Then electron loss will start first from the outermost shell before coming to the next shell. And since this is the outermost shell, in the build-up, it has to enter 4s because the energy level of 4s is lower than that of 3d. But in the removal, electron will first be removed from the outermost electron shell before it comes to the next shell before it. So I'm going to have 4s0. That means one of the electrons has gone out of the 3 electrons lost, and 2 will now be lost from the 3d3. Now copper has a similar case with that of chromium because its own is 29, chromium is 24. Now let's write for copper too. 1s2. By the way, if you want to confirm if what you are putting is correct, 2 plus 2, 4, 4 plus 6, 10, plus 2, 12, plus 6, 18, 18 plus 1, 19, plus 5, 24. I see this is 24 already. And if this is 21, 2 plus 2, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, that's 18, 18 plus 3, that's 21. And don't forget, I believe by now, you should remember the maximum number of electrons each of these shells can take. S can take a maximum of 2, P can take a maximum of 6, D can take a maximum of 10, and F can take a maximum of 14. Though we are not writing any of these up to F. None of these can reach F. So 1s2, 2s2. We are writing for copper now with atomic number 29. Like I said the other time, when element is in the ground state, atomic number is the same as the number of electrons. Atomic number number is number of protons by definition, but because it's already in its ground state, it's not carrying any charge, the number of protons is equal to the number of electrons. 1s to 2 2p6, 3s2, 3p6. Then I'll have 4s and 3d. Now, many will jump to say 4s2, 3d9. No, that's not the correct way of writing it. The same approach that happened to chromium is very similar to what happened to copper here. Now, the 9 electrons here will be at this 1, 2, 3, 4, 5, 6, 7, 8, 9. Because only one is left empty, it's not going to be in a stable state as such. So there will be an excitation of one of the electrons of this 4s, leaving one here and making this one 10. Okay? So the correct configuration for copper is what is just being written on the board now. So it's 4s1 3d10, not 4s2 3d9. And of course Cu2 plus means it has lost 2 electrons, 27. Electron is going to be lost first from the outermost electron shell before it goes to the next cell before it. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, one of the electrons has been lost, then 3d9. This is for Cu2+. I believe you got the understanding on how to write the configuration for chromium is a ion, copper and it's a ion. See you in the next class.